Hello, everyone, and I hope you guys are doing well in these terrible conditions. My name is Satyam Sangeet, and I have started this channel in the hope that I might find like minded people who think about the topic that you are seeing in front of you, that is quantum physics and consciousness, in the same way that I do. Now, the reason that I've decided to start off my channel with this particular video is because so first, let me be very clear that this particular channel will be dedicated to this particular field, that is consciousness, and targeting the question of consciousness or the neurological aspect or the neuroscientific part from a computational as well as experimental and quantum mechanical point of view. Now, the reason that I think about this so much is because I believe that the very basis of the formation of biological system, quantum phenomena does play a role in it. For example, there has been various literatures out there that have uh, showed the presence of quantum effects in biological systems, such as in the activity of enzymes or in photosystems when plants perform the photosynthesis, or even in the avian magnetoreception and the more complex phenomena that has started to come is consciousness. So I hope that on the way, so I have interacted with many people who have opposed the idea that there is a particular thing such as consciousness, and that might be an aspect, and I'm ready to believe that as well. But we shouldn't just nullify it all the way through without even considering the other side of the story, that what if there exists a certain thing known as consciousness. Now, the reason I'm seeing this, or I am starting my head off, is because I have faced a lot of skeptics on my way when I talk to them about the presence of consciousness. I get a straight away no that you know which kinds of put me off, but I never left myself or I never fell downwards by the note that I was getting, because I've always believed in the existence of something known as consciousness. So I hope that along the way, this video reaches a group of enthusiastic people who think about it in the same way that I do. So that's why I've started off with this particular presentation, and this is the presentation that I made when I was pursuing my master's. So let's start it off. So, quantum physics and consciousness. Now, before proceeding on with the term quantum physics or consciousness, we have to understand certain aspects, or we have to first understand why we are targeting this particular question, or what is the need to target this particular question. So, for those who have a background in quantum physics, they might be well aware of the quantum phenomena, but not much aware about how does it play a role in biological systems. And those who are having a background in biological systems know very much, or they are well versed with the biological systems, but not with the quantum mechanical or the quantum effects. That's what I'm assuming. So I just want to bridge both of these things together. So the first question that we need to ask is, what is quantum physics? Now, as you might find the basic definition everywhere, that quantum physics is the branch of physics, or a branch of quantum mechanics that deals with the nature of subatomic particles such as electrons or protons, neutrons, gluons, pi mesons, etc. Right? And how does these particles, or the subatomic particles, how they behave when they are subjected to different kind of effects? The next question that comes to mind is, what are the quantum effects that actually play a major role in biology? Now that we are talking about the amalgamation of both quantum physics and the biological world, we need to ask ourselves, what are the certain quantum effects that actually play a major role in biology, or in the biological systems, or those who find a presence in the biological systems? Now, I'll be defining each of these effects in detail as I go along, But just to give you a very precise, or just to give you a very layman overview of the types of quantum effect, we are talking about quantum superposition or quantum entanglement, quantum tunneling. These three are the major quantum phenomena. So there are various quantum phenomena which are out there, but I believe that these three are the major quantum phenomena that we know as of now, according to the literatures that are out there. Also, the next thing is, what is that particular transition point, or what is that particular transition uh, position where where actually the transition happens from quantum physics into our everyday world? Like, how is it like interweaved into each other in such a fashion that there isn't a transition point, or is there exactly a transition point where we say that, oh, at this particular point the quantum world gets intermingled with the biological systems. And last but not the least is, how will life science fit into the picture, and how can we define, so whatever phenomena that have been defined as of now, how can we define more complex biological systems in terms of quantum mechanics? For example, and these phenomena can be anything from molecules up to trees or elephants, or even the most complex machine that humans have ever faced is human brain. Now, there is a very growing debate, or I would say there has been a debate out there between neuroscientists and physicists, saying that, or putting forward the point of view that these two are very different world. We can't bridge both of them. We can't see them. We have to see them distinctively. They are both different world, right? We can't join them together. But there are also a group of people who actually think the otherwise. They think, and I would like to think in their point of view as well. Like, why can't we think of both of these world together, right? So the arguments or the criticism that we are faced here is that there are two main arguments which are raised against the quantum brain hypothesis. Now, this is, I know it's a very high jump before starting off anything. We're just talking about quantum brain hypothesis, but it's essential to know in the long run, right? As I started off, it will be easier for us to keep these arguments in mind, and hopefully we can tackle it all together. So the very first argument that we face is the neuronal signaling molecule, the neuronal signaling in the form of molecules or neurons or the neural networks, they are too large for quantum phenomena to play a very significant role in the function. Now we know that to actually visualize a particular quantum phenomena, or to see a particular quantum phenomena having a certain outcome, the environment should be very cold. Right? We have to control the subatomic particles in such a way that it doesn't all go haywire. But we know that the environment in which the neuronal signaling happens, or the signaling in a neuron happens, the environment of the brain is not very cold. It's a wet, warm, and very noisy environment. It's full of stochastic noises out there. So the very first argument we are faced is that because the environment in which we are trying to incorporate the quantum phenomena is a very different world altogether, there is no point that quantum effects will play a role in such an environment. And the next argument that we are faced is, and I believe it's the most important criticism, is that the interaction of neuronal molecules or neurons and neural network with their noisy, wet, and warm environment will destroy any kind of non-trivial quantum states such as superposition or entanglement. Because these quantum states such as superposition and entanglement, they require us to work in a certain defined conditions, but the stochastic behavior in which the neural signaling happens in our brain, it might not be true for those of the quantum states. So how should we target this particular question? I believe by going together and understanding each of us, and the ideas that we can put forward to target this particular question. I believe we can have a good overview of how we should come up to this particular question and how we can target it from various aspects. Now, the possibility of the impact by quantum events. Now, I was going through the paper of Satinova and Jedlicka, And they have said that there are two alternatives but interrelated ways in which quantum events may influence the activity of the brain. Now, the very first is the non-trivial quantum effects can speed up the computational process in living organism at the microscopic level. So, what they say is that although we are saying that the environment in which the signaling happens, the neural signaling happens, is pretty much non-trivial, but because the environment is non-trivial, it might speed up the computational process of our brain. For example, the ETC in photosynthesis, the electron transfer chain in photosynthesis, whereby the electrons are transported when a particular wavelength of light falls onto the photosystems, and we see the Z-skin pathway in action, and we see how the electrons are transported, and finally the food is processed. Right? And the next alternative is the non-linear chaotic dynamics. It can amplify the lowest level of quantum fluctuation upwards, modulating even larger scale mesoscopic and maybe also the macroscopic neural activity. Uh, what they mean here is that the nonlinear dynamics of the signaling that is happening in the neural sense, what happens is that the fluctuation is so high at the quantum level, at the lowest level. The fluctuation, whatever the fluctuation is happening at the subatomic particles, these fluctuations can act in a bottoms up approach, and it might even influence. So, the very fluctuation at the lowest level might be able to affect the final outcome at a macroscopic level. For example, in avian magnetoreception, whereby the birds, whereby the avians, different birds, for example, like Siberian birds, they are able to find their precise way every at a particular season. Right? They find the exact particular way. They know where they should go and where they will find the food. So how is it happens? Is like is there any inbuilt map in the brain, or how does it happen? So I hope we can target these possibilities of quantum events. So, what do we mean by non-trivial quantum states? So, the various phenomena that we will be talking here is, so I would like to tackle the main two effects out here. The first is the quantum entanglement. Now, quantum entanglement is a physical phenomena whereby we can say that now when we talk about entanglement, we know that when two things get mixed with each other, for example, two threads, right, they are entangled with each other. But what happens in quantum entanglement is that it's a phenomena whereby we are talking about a pair of particles or a group of particles, and these two particles are interactive, or they are intermingled, or they are entangled with each other in such a way that whenever we try to change a particular state of one particle, the state of the other particle automatically changes, right? Because they share a certain spatial proximity in such a way that the quantum state of any one particular particle cannot be described independently without describing the quantum state of its pair, opposite pair, right? For example, let's think about two electrons. Now we know that a set of when we write the electronic configuration of an atom, we describe it in by the four quantum states, or four quantum states, such as n, which is the principal quantum state that will actually define in which principal shell the electron is. The next is the the azimuthal quantum number, which will describe the orbital in which the particular electron is. The third is the and so for example, like there is n, which is the principal quantum number that will basically describe us or tell us the principal shell in which the electron is, that is k, l, m, or n. The second one is the angular momentum quantum number that will describe the shape of the subshell and its orbital, uh, and it's denoted by L, and the value of L will describe which particular orbital it might take, or the subshell is there the electron will take. For example, if the L value of L is 0, we can see that the electron is present in s orbital. If it is 1, we say it's p, d, or f in a similar way. The third is the magnetic quantum number, which is described by ml, and it describes the orientation of the orbital within the subshell in space. That is, and the value of ml, the possible values of ml ranges from minus L to plus L. For example, if the value of L is 0, then the value of ml is 0. That means for s orbital, the value of ml becomes 0, right? And if the value of L is 1, that is, if it's p orbital, then the value of ml ranges from minus 1 to plus 1. That is, it can obtain three values: minus 1, 0, and 1. That means these three corresponds to three orientation of the p orbital, that is either x-axis, y-axis, or z-axis, right? In the similar way, it is for d orbital and f orbital. And the final is the spin angular momentum quantum number, or spin quantum number, which is denoted by ms, and it has only two values, that is plus half or minus half, because the electrons can either have a plus half spin or minus half spin. Now, if we consider, for example, let's say if we take the consideration of spin quantum number. So let's say if there are two electrons which are paired up all together, right? And now we know that every system in this universe tries to be in the state of equilibrium. So if one electron spins, or if one electron has a spin of plus half, then obviously the spin of the other electron will be minus half, so as to cancel out each other, and so that the system remains in equilibrium, right? Now what happens is, let's assume that these two electrons are paired up, and one electron is with us and the other electron is millions of light years away from us, right? And if we know the spin of the electron that is with us, we will automatically know the spin of the electron that is million of light years away from us, right? And if we somehow change the spin of the, for example, let's say the electron that is with us, it has a spin of plus half, then we already know to neutralize the, to attain the equilibrium, the other electron will be having the spin of minus half. But if we change the spin of the electrons, if we change the spin of the electron that is with us from minus half to plus half, then automatically the spin of the other electron changes from minus half to plus half, so as to maintain the equilibrium, right? So this is what quantum entanglement is. So they're entangled in such a way that even if they are separated by a long distance, the quantum state of each particle cannot be described independent of the other. The second is quantum superposition. Now, what does quantum superposition say? So the feature of a quantum system, so the quantum superposition basically means, it is defined for a system. So it basically means that it is a feature of a particular quantum system whereby it can exist in several separate quantum state at a particular instant of time. And the very best example of quantum superposition is nothing but the Schrodinger's cat. So we know whereby we say that the cat is dead or alive at the same instant of time. So that is, it has two states, that is, cat can be either dead, which is the first state, or it can be alive at second state. And at a particular instant of time, the cat is both dead as well as alive. So that's why we say that there's a 50-50% probability, and it is defined by a certain wave functions, which I will be describing in my next video. So I hope you guys have understood up until now, and hopefully we can target the other aspect of the quantum states in the upcoming videos. So if you guys like the video, please give it a big like and subscribe to my channel, and give your ideas in the comment down below, so that we can share our ideas together and we can collaborate and hopefully come up with certain ideas that might prove beneficial for the future use. Thank you.